Thank you for having me. I'm really low key, so yeah, feel free and ask me questions if you have them while I'm talking. So I've been working on springs in Florida for 19 years. Most of that work has been at Volusia Blue Spring down in Orange City near me. But after a while, I felt a little provincial, only working in one spring, although I got to know it very well, which is helpful. And so I started spreading out and I started looking at other springs around Florida. And then I spread out even a little farther and I started looking at springs around the country, and I'm kind of in the middle of that project right now. So I'm going to talk a little bit about some of the things that I've learned over the course of this study. So I'm coming at this from a standpoint of resource management and protecting our natural resources. And your perspective on how you feel about natural resources probably depends upon your perspective, like I put up there. By the second perspective, I mean how far away you're looking at it and what angle you're looking at it from. So I grabbed a couple pictures off Google Earth, as you can see right there. That one is obviously showing all of North America, and it's from about 3,000 miles up. If you look at North America from 3,000 miles up, it probably doesn't look that different than it looked 200 years ago or something. You can't see most of the cities on there. You can't see most of any sort of human development at that height. So if we go a little bit closer, now we're looking at Florida, obviously, and now we can start to see the cities. It still looks very, very green, as did the last image, but now we can start to see the cities. So we can see the development all along the center of the state, where Orlando and all of its outliers are. We can see where we are right now. I'm terrible at these pointers, but you know, we're up in here right now. I think that's right. And you can see Jacksonville, and this should be Tallahassee, I think. So now you can start to see some of the development, and it doesn't look quite so untouched as it did when we were 3,000 miles up. Now we're about 600 miles up. And if we go even closer, then wow, it looks very, very, very different. There are patches of green at this point, but there's also a lot of city. And you can see a lot of city breaking up the green. So for example, if you were, say, a bear trying to get from South Florida up to North Florida, north of Palatka, you'd have to do some work if you were trying to avoid going through people's backyards. Maybe a better example would be a panther, because a bear might go through somebody's backyard and eat its garbage, but a panther won't. A panther wants things to be pretty green. And so it might have to kind of wander over here, or maybe it wanders up this way, but it's got to do some work. And to get over I-4, oh, forget it, right? So when you look closer at, say, 100 miles above Florida, the natural resources look a lot different than when you look up much higher. And like I said, it also depends upon sort of what angle you take, how you feel about it. So we disappear, those broad swaths of land that we were looking at before kind of disappear when we get closer. So why does this matter? Well, like I said, it's harder for the panther to get up there. I'm looking at this, though, from a different perspective. I'm looking at it from water resources, and I'm thinking about how water gets into aquifers and then how those aquifers affect our springs. We can look at aquifers from a lot of different perspectives as well. We could look at it from my perspective of, I really like springs, but we could also look at it from the standpoint of people's drinking water. I don't know if you guys know this, but all of your drinking water comes from the aquifers. This isn't the case everywhere in the country. Up where I'm originally from in Michigan, it's all surface water. They're drinking water out of Lake Michigan or Lake Erie or whatever, not out of the aquifer. But here, it's all aquifer water, and that's continuous with our spring water as well. We also drink spring water, but not usually straight out of the spring. It's out of a bottle usually. So to understand how this works, you kind of have to understand how springs form and what they are. So this image is an image of our aquifer. And the aquifer is basically just a bunch of limestone under our feet that's been dissolved. And so if in this image, we have what's called recharge in upland areas. the water will percolate down when it rains in the sand. And if there's not too thick of a layer of clay, it'll percolate down into the limestone and get down into these holes in the aquifer. And it can travel through the aquifer. It can travel laterally through the aquifer. And it'll stay down there. In some cases, it'll be under high pressure. So if there's a lot of water coming down here and the water's moving that way, it gets pressurized over here. And it'll stay down there if there's a layer of clay. I don't know how many of you guys have touched clay before, but clay is very dense, right? Like if you've ever tried to do any pottery or sculpture or anything, it's super, super dense. It gets slick. The particles are really small and it packed together really, really well. So water doesn't go through it very well. Water just like beads off of it. So wherever there's a layer of clay, which is this orange intermediate confining unit, the water will stay down there because it can't get through. But where that layer of clay disappears, well, that's where water starts shooting out, especially if it's under pressure. And that's what our springs are. So how much water you have coming out of your spring depends upon how much water you had in your aquifer and what kind of pressure it has in the aquifer. And that depends upon how much water came in through these recharge areas. So for any given spring, there's a spring shed. Maybe you guys have heard of watersheds. They call the area around rivers where the water runs off the landscape into the river. They call that the watershed. Springs have spring sheds as well. And the spring sheds are a little bit different because the water doesn't run off into the spring. But the spring sheds are where the recharge is. And so in this big area, maybe I should use my pointer, in this big area, all through there, we've got water percolating down through the sand, through the limestone. And that water picks up a little bit of acid as it goes through the air, through the carbon dioxide, which makes it a little bit acidic as it goes through the air and through the water and makes holes in the limestone to make the springs. And one thing I wanted you to see on this is, number one, that's the spring shed for Volusia Blue Spring, my home spring. But one of the things that's interesting about this is nearly the entire spring shed is inhabited. So the spring shed is made up of DeLand, Orange City, DeBerry, and Daytona. And in some cases, the density of houses is quite high. So for water to get down into the aquifer, it has to be able to get into the sand. Guess what happens when you build a neighborhood? You now have cement. Water doesn't percolate down through cement. So that affects the recharge of water into the aquifer, which then affects the ability of the water to come back out because you reduce the pressure. Incidentally, this is also it also is related to sinkholes. If anybody is ever worried about sinkholes, a sinkhole happens when you've got in your aquifer, you've got these limestone caves basically that are filled with water. And if you don't get enough recharge and you have people withdrawing for your wells, then the pressure in the aquifer declines, and there was water holding the roof up, but when the water level declines, there's nothing holding the roof up anymore, and it collapses, and then you get a sinkhole. That's incidental to what I'm talking about today, but probably gives you an idea of sort of what the kind of pressure we're talking about. Okay, so all of the springs in Florida, all the springs everywhere basically have these spring sheds like this. They vary in size, they vary in how much development there is in the spring shed, but they all have them. So springs around here, like Volusia Blue or Gemini Springs, down by Sanford, closer to Sanford. Actually, it's right here, which is closer to Sanford. But and Delian Springs, all of those springs have a fair amount of development on them. But if you go further towards the center part of the the center part of the state, then you'll get into springs that have more agricultural spring sheds, for example. Okay, so why do we care about this? Well, hopefully I just gave you an indication of why you might care about it because, well, number one, they're cool. But number two, they are actually a window into your drinking water. This is Ginny Spring, one of the springs in Ginny Springs. And we have this huge diversity of springs here. They're gorgeous. So many different sizes and shapes and lengths and depths and colors. And it's really phenomenal if you start traveling around the state looking for them. So this one's Ginny Springs. This one's Rock Spring, which is in Apopka. This one came out a little blurry when I blew it up, but it's so pretty. It's got this gorgeous run. The water comes out of a cave instead of out of a hole like in Ginny Spring. It comes out of a cave and then travels down the run. People use it as a tubing run because the water goes shooting down the run. It's got all these big rocks, hence the name Rock Spring, right? This is Silver Glen Spring. This isn't actually the main vent of the spring. It's what they call the chimney, which is right next to the main vent of the spring. And people aren't actually allowed to go over there, but they let me go over there because I was studying it. And those are actually sunshine bass and striped bass. Nobody really knows why they do that. They're just swirling around in a circle in this little vent on the spring. It's really crazy, but it makes for a nice picture. This is Otter Spring, lovely spring over on closer to the west coast of Florida. This one is Troy Spring. That's the biggest vent I think that I went to. Well, no, that's not true. Wakulla was bigger. This was one of the biggest vents that I went to. This is the edge of the spring and it drops off. And when I was paddling around it, because it's huge, the vent goes halfway to where the line of buoys is. And as I was traveling around, there were tons of turtles. All these turtles were shooting off because I was startling them. They were shooting off into the vent and it looked like they were flying off into space because it was so deep. Just beautiful. That one's flowing into the Swanee River. So where that line of floats is the Swanee River right there. This one is Little Blue Spring. This also flows into the Swanee River. Just gorgeous. This one is Peacock Spring, or one of the springs at Peacock Spring. This one is Peacock Springs is famous for divers. It's now called West Skiles Peacock Springs for the in memoriam of West Skiles, who was a very famous diver who passed away. But this has this whole series of these little karst windows, these little holes into the aquifer. It's really amazing. That is the green is actually duckweed, and those are divers coming up there. There's lots of people who do test dives there and stuff. Just out in the middle of the forest. You're driving through forest land, water management district land, and here you are, and here are all these springs. This is the craziest spring that I went to. This one's called Falmouth Spring. Oh shoot, I forgot the name of the website. There's a website for crazy places. I can't remember what it's called right now. But this is on that. I mean, it's like a national thing, and this spring is on that. They call it the shortest river in the world. And this spring is one of those sort of disappearing springs. So it's coming off the Swanee River, and the water comes out at one end. And it's just, the whole thing is just like sort of a crack in the land. Again, walking through the forest, and then here's this big old crack. And so the water comes up out of a hole, a deep hole, and it was brown because it had river water coming into it. So I couldn't see the bottom. Water coming out of this hole goes down this little tiny run and then disappears into a limestone wall on the other side in a spiral. I felt like I was going to get sucked into the wall. It was so crazy. And this is almost the whole thing, just in the middle of the woods. This is the biggest one. This is Wakulla, and I don't have a picture of the whole springhead because it's huge. It's enormous. It's 4 times. This is like just one stretch of the spring boil. It's enormous. This one is amazing because it's one of the springs with the longest history of protection. It was owned by some millionaire who built railroads or whatever in the 1800s. And when he died, he bequeathed it to the state with the understanding that there would never be anyone on the spring except people who worked on it. And me, it was great. They let me go, and I was traveling around filming fish. So I'm out there completely by myself in this gorgeous spring run that no one ever goes on except they have a tour boat that loops around so people can get out on it. And they have swimming right in the boil, but that's it. The whole rest of the run until you run out of the park is all protected. It's wonderful. So like I said, you might care about it because they're cool. You might also care about springs because they, sometimes people think of them as sort of a canary in the coal mine for our drinking water because that is exactly what we're drinking. That's Devil's Den. Again, it's just a cool picture. So it's an awesome place. It's another famous place for diving. So if for no other reason, you might care about them because you're drinking that water. So our springs are gorgeous, but they're not all in great shape. So this is a picture of algae at Silver Glen Spring. And Silver Glen is one that's in Ocala National Forest. So it doesn't have a lot of development around it because it's in the forest, right? And it doesn't have a lot of agriculture around it either. And yet here we are with this crazy algae. This is a picture from my video footage, because I use video to count fish and I evaluate fish assemblages using GoPro cameras. This works great. It's really fun too. And that was the best video that I could get out of Delian Springs. It is so turbid and there is so much sediment at the bottom. You put the camera down and it goes poof, and you have to wait 2, 3, 4 minutes for the stuff to settle out to see anything. And that's a good image. Most of the images I had, I could barely make anything out. I could get the shape of the fish and that was about it. So they're not all in great shape. And this got me thinking about things. I've been thinking about this for a while in a variety of ways. This just shows you how many we have. First magnitude springs have more than 100 million gallons a day. And so all those blue ones, all those blue dots, those are all first magnitude springs. We have a lot of very big springs, which is unique. There aren't a lot of places in the country that have springs like that. This is special for us. The green ones are a little bit smaller, the orange are even smaller, the red are teeny tiny ones. And there should be a lot more red dots on there. We don't even know where all the springs are for the little tiny ones. We have so many springs. This image is Salt Springs, which is again in Ocala. It's not that far from Silver Glen Springs. And so you can see that most of the landscape around Salt Springs as it flows into Lake George is not very impacted. And yet, Salt Springs also has crazy algae at it. A lot of our springs had a lot of eelgrass originally. And then in the last decade or so, all that eelgrass is getting covered up with algae. So when I was videoing there, the eelgrass was like poking up out of the algae. Like the eelgrass would be, down to my elbow and I could see that much of it, and all the rest of it was algae. That's not great. That's not really what we want to see. So one of the ways the state is trying to deal with these problems, and we've got a couple of different problems with these springs. I was just mentioning water quality, but we also have problems with water quantity. You guys know we live in a popular area, right? There are a lot of people moving to Florida all the time, and they're all drinking groundwater. And to a certain extent, they're using groundwater to water their lawns and wash their cars and all of that stuff. All of that groundwater that they're using is competing with the water that's supposed to be coming out of the spring. So one of the ways that the state has tried to deal with that is they started what they call a minimum flow and level program. So for a lot of lakes, they set minimum levels, and for a lot of flowing water, like springs, they set minimum flows. Okay, that's great. That's a good start, except that for all of the springs, except for Volusia Blue, my home spring, they set the discharge at an amount below the historic means of the springs. So they're saying the minimum flow, so where we need to keep it, it's below what it was before. And in some cases, those numbers are actually way below the historic mean because like for this one, which is Delian Springs, which is down their minimum flow. So how much water is going to be coming out there? It's about 9% what the historic mean is, but they took 9% of the data, they made that 9% of the numbers that are down here, and that's already reduced from what it was like back in the 70s. So their baseline is shifted down, and now they're saying we can shift it down a little bit more. So I definitely understand why this is happening. I get it. I totally get it. But at the same time, I'm a little frustrated because these are some amazing places. And I've been surveying at Volusia Blue. I actually do the minimum flow surveys for fish and snails for St. Johns River Water Management District. We're just about to start another one. And so I'm helping them with these projects. And I can tell you that reducing the discharge is not great when you look at the fish diversity and whatnot. By the way, Volusia Blue is the only one that has the minimum flow set at its historic mean because it gets like 500 manatees. And so manatees are protected, and people love manatees, so it's great for Volusia Blue. It's awesome for Volusia Blue. But these other springs that don't have 500 manatees don't get quite the same level of protection. So thinking about all of this, first I go to these meetings about minimum flows and levels, and I try and bring up ecological things, and they're like, bah, bah, hush you. So I get frustrated. And so I started thinking, well, how can I make this point stronger? So I started thinking, well, maybe I need to scale my perspective up. I need to move up. And if I move up and I can show it's a bigger problem, maybe I can convey this better. So I started looking at patterns of change in spring discharges around Florida and around the country. So how do I do this? So this is a website. USGS collects data on spring discharges for springs around the country, and I don't know if any of you guys have heard of GIS, but it's a way of mapping things, and they can make layers for different things that you might want to look at. In this case, they've got layers for surface water, for groundwater, like wells, and they've got layers for springs. So right here, I'm showing you when I click springs, these are all the points that I get. So we do have a lot of springs here. There are lots of springs, lots of places. We just happen to have lots of bigger ones. A lot of these other dots and other places are very, very small springs. So I've been going through these dots. I first went through the dark purple ones. You guys probably can't see that very well, but we got some real dark purple ones. In Florida, we have better coverage of data collection than in a lot of parts of the country. So I've been harvesting these long-term data sets, and we've been collecting data for a long time too. I have data sets that go back to like 1898. And so I can see exactly what happened to the amount of water coming out of that spring over the last 100+ years. So I'm trying to find data like that for other places as well. So if I start, these are the places I've looked at so far. I'm not going to talk about Pennsylvania today, but we'll see how time goes. But I'm going to start with Florida, and then I'm going to move to Texas, and then I'm going to move to Idaho. And we'll see how far I get. If I don't get all the way, it's okay. So we start in Florida. This is an image, again, kind of blurry, because you got a great, big, beautiful screen, and then my images look a little blurry. So this is showing the aquifer in Florida. We have one big, giant aquifer. It varies in depth. So the shallowest part is up in North Florida. The deepest parts are down in South Florida. But it's all one aquifer. It's called the Floridan Aquifer. And all of our springs are coming out of the Floridan Aquifer. So, like I said, I'm looking at long-term data for springs. And so I'm going to show you a series of these time series so that you can see what's going on. So I have 3 of these images like this with all these different counties in Florida. And these are different springs. And I'm going to show you the data. The data are underneath the images. So the first one is Wakulla. The second one is Homosassa. And obviously I'm showing you where they are in Florida. So, sorry, I just hit the laser on somebody. So for Wakulla and Homosassa Springs, so in my images here, I've got data from 1900 or 1920 up until the present, and then I've got discharge, CFS is cubic feet per second. So that's cubic feet of water coming out per second. And for Wakulla, which is huge, like I said, we've got up to like 1,200 cubic feet per second. So cubic foot, like this, right? 1,200 of those per second. That's how big this spring is. It's huge. And And it actually is doing fine in terms of discharge. It's not declining. It's got this really funky plumbing under it. It flows both directions sometimes. And yeah, it's real interesting. And Homosassa Springs also has no significant difference in discharge over time. But those are just the first two. The second ones, I've got Madison Blue up here, Lafayette Blue. There's a whole bunch of blue springs in Florida. And then this one is Manatee Spring. So if I look at these guys don't show significant declines because I've got these p-values. I don't know how much you guys know about statistics, but those are probabilities that I have something real going on here. And so my probabilities are actually, I did that backwards. They're probabilities that my pattern is junk, is really what it is. So I have a 10% chance that the pattern that I think I see is not real. But you'll also notice that I've got real spotty data for these guys. And the most recent data is pretty low on all of these. So it's possible that there's something going on. I just can't pick it up because I don't have enough data. But now if I move over a little more, now I've got, Ichetuckney Springs, Rainbow Springs, Silver Springs, and Silver Spring and Rainbow Spring are other giant monster springs. Here's my Volusia Blue right here, and Sulphur Spring, which is in Tampa. Just to look at these pictures again. They vary in how much how much development there is around them. But all of these guys are showing significant declines because all of my p-values are very small, which means I have a very low probability that this line that I'm seeing here is not a real line, so like this guy with a p-value of less than 0.0001, that means I have a 0.001% chance that this decline that I'm looking at isn't real. So all of these springs are declining. So what's the upshot there? Well, the upshot is half of the springs that I've looked at are declining. Yeah, that's not what I wanted to see. I wasn't surprised, but that's not what I wanted to see. If you want to look at the good side, half of them are not. That's a happy news. Half of them are not declining. And the other happy news is that in Florida, our aquifer is quite shallow. This is another reason we get all these sinkholes and stuff, because our aquifer is shallow. So we have a lot of interaction between, even though it's underground, we have a lot of interaction between what's happening on the surface and what happens in our aquifer. That means that if our springs are declining in discharge, they could come back. And it wouldn't actually take that long for that to happen because the water's percolating down relatively quickly and it doesn't have very far to go. Okay, so there's Florida. Half of them declining, half of them not, for the ones that I have data for. It's just a pretty picture of bass. That's from Peacock Spring, that one that I was telling you that's in the middle of the forest named for the diver. Nice bass picture. I have a lot of pictures. I threw a couple pictures in here because I thought it'd be fun to look at pretty pictures. I have a lot of pictures when I do fish videos of sunfish doing that in various angles. For whatever reason, spotted sunfish, which is what this is, really like cameras more than any other fish I've seen. So I have all kinds of pictures like that. That one's from Rainbow Spring. But another thing that's nice is you can see how clear that is. Super, super clear. Peacock too, really, really clear. And then I have a little video if it'll play. Yeah, there we go. So this is what they call a bluefin killifish. That's one of the most prevalent fish in the springs that I've seen. It was in every single spring that I saw. Mosquito fish, if anybody knows mosquito fish, they're everywhere. I didn't realize that one was just flaring its fins for mating. Those fish were going to be quite so prevalent. It's interesting because our springs, it's wet in Florida, right? It's real wet in Florida. And our waters are really connected to each other. So all of those fish that I just showed you, they occur in pretty much all of our springs, all of them. When I originally went out, I was trying to separate springs by their fish. I couldn't because our fish are so similar between all of our springs. That's going to be a little different from Texas. We'll go to Texas. So let's turn to Texas. Texas is different.
Can we stay in Florida a second?
Yeah.
So we're getting just the rain's still coming down.
Yes.
And because there's development, the water is not getting into the sand and not going
Correct.
away. Is it evaporating away? Is it running off into the rivers? Where's the water going?
Oh, that's a good question. So a lot of it will run off into stormwater. Yeah, it goes in the stormwater drains and into retention ponds. And there could be percolation off retention ponds, but the area of a retention pond is so much smaller than the area that it would have been raining on in the past.
Is the water like pressure?
It is. That is true. But I think still because the area is so much smaller that on balance, the recharge is a little bit lower than it would be otherwise. But you're right. There is more weight of water, and so that probably does increase the percolation a little bit, but in a very concentrated area. And it also matters where they put the retention ponds too, because not everywhere has great percolation. So I imagine some of them are in places where it will percolate and some of them are in places where it won't. Mm-hmm. So feel free, ask me other questions if you've got them, especially if I'm not being clear. I always think I'm clear, but that doesn't mean I always am. Okay, so these are the aquifers of Texas. It's not one aquifer like in Florida, and they're very different. So the aquifers in eastern Texas are real different from the aquifers in West Texas and the Ogallala. I don't know if you guys have ever heard of the Ogallala. Yeah? It's really deep, right? Ogallala is our biggest and deepest, I think this is true, aquifer in the United States. That's the aquifer that they irrigate all of Texas agriculture, Oklahoma agriculture, Kansas agriculture, Iowa agriculture. It's a whole bunch of it's coming out of the Ogallala aquifer, and it penetrates down into the panhandle of Texas. So these aquifers are really different from each other. In Florida, although not all of the water is connected, the aquifer itself is fairly similar throughout. It varies in how thick the confining unit is on top of it. But in Texas, it's really different. So these aquifers behave very differently than these aquifers do. In eastern Texas, it's kind of green, not quite as green as we have here, which is why I like it here. It's so nice and green. But it's a lot greener than it is in West Texas. So for example, this is a spring, this is Barton Springs. That's right near Austin. I think it's just south of Austin, but like people go there from Austin to go swimming. And you can see it's real green around there. I mean, it still looks like you're in Texas, not in Florida, if you get off the path or whatever, but it's fairly green as opposed to West Texas. So this is near Alpine, which is right above Big Bend, and this looks like the Southwest. And this is the same state, right? We just went from East Texas to West Texas. Very, very dry. And it had these cool cactus-y looking plants that aren't actually cacti. I can't remember what they are, but they're really, really cool. They're tall too, they're like that big. Road runners, stuff like that. It's west, it's dry, very arid. This is actually a stream bed. That's what their streams look like when it's not raining. I was there in July, so it was not raining, and it all dried up. And this is what happens. So very different than what we have here, right? Our streams, rivers, whatever, they're always flowing. Just vary in how fast and how much, but they always have water in them. So what they have is they have a few springs, and their springs are super important for them. So this is San Solomon Spring, which I'll show you a picture of in a second, channelized so that they can provide water to agriculture in the town of Balmorhea. And so the town of Balmorhea is here because there's a spring here. And yes, we have towns that are centered around springs as well, but ours are not quite as important as they are here because you can see how dry it is around there. This is San Solomon Spring, and so like Delian Springs or something like that, they made a swimming pool around it. This is so important to the area that when I went, there's a diving board over here, and over time the rock had sort of eroded and the diving board was falling in, so they shut the spring for swimming. They had a big LCD sign out on the highway to tell people don't bother coming in here. That's how much people rely on this spring for water, for going swimming. They don't have swimming pools. Their swimming pools would just evaporate. So they don't have swimming pools in this area. They go to the spring to go swimming because that's the only water to a large degree. And so that channel that I showed you in the picture before, that channel is continuous with this right here, and you can see it is irrigating their crops. They would not have those crops if it were not for that spring. And this is the canal going into the town of Balmorhea. It goes right through the town. The spring is the centerpiece. You know, the canal from this with the spring is the centerpiece of their town. Okay, so I did a couple of things with Texas. I went out there to meet some people and learn about the springs out there, and they suggested that I look at this book called The Springs of Texas from 1980. It's 500 pages long. This guy, Brune, he must have spent years doing this. He went to every spring in every county that he could find. I'm missing some data in the middle. I think I need volume 2. But he went, all of these counties, all those boxes, those are all counties in Texas. They got 1 million counties. And he went to all of them and went to their springs and looked at whether they were running or not. In some cases, measured their discharge, these little tiny springs, talked to people. He wrote down historical artifacts and stuff like that. It must have taken him forever to do this. So I went through his list, all of these counties, and I counted up of the springs that he went to, how many of them were flowing, how many of them were drying or dried. And so I made this figure showing the ones that are the darkest red are showing 75 to 100% of the springs in that county were drying or dry. That the next category is 50 to 75% are drying or dry, 25 and so on and so forth. You get the idea. Gray is no data. And what I wanted you to see is that in the springs in the Ogallala Aquifer, even back in 1980, they were drying. And in the springs over the Pecos Aquifer, this is West Texas, this is what I was just showing you, that area. San Solomon is like right in there. Those were drying, a bunch of them were drying then. Springs along the coast there where people were living then and now, those were drying too. In the green part, where that first one that I showed you, Barton Springs, that's in this area. That was looking okay back then. I have to admit I don't have a lot of data for Texas, but I do have some. So all of these springs are in that green part, kind of in the vicinity of Austin, and there's a bunch of beautiful springs there. There's Barton Springs again, and here's some other springs. I'm not going to go through all the names because you guys aren't from Texas, I'm imagining. Yeah, San Marcos. Mm-hmm. And so these are, like I said, these are in the greener part, in the eastern aquifers. And all of these springs, they had lots of data for them. All these springs are doing okay. All of my p-values, all my probabilities are insignificant, which means there's no trend in any of these data. So they're all doing fine. In some cases, partly I think because it's wetter there, but also in some of these springs they have endangered fish or threatened fish or salamanders, like Barton Springs has a salamander that's threatened. So they've put down conservation measures on these springs as well to make sure that the discharges stay high so they can protect these fish or salamanders or whatever. But, and like I said, I don't have a lot of data out here. For West Texas, I've got this Dove Creek spring. That's in the area where I don't have any data from Brune. But for these two, and there are not a lot of springs out there either, but the two that I have, they're both dropping. And here's San Solomon. And this actually would look more dramatic if this one point were there, which might be a mistake. But this is a significant decrease in discharge, and which is not good for West Texas that relies on all of this water, right? So in the area where this guy back in the 70s said they were having a problem, they're still having a problem. And in the area where he said they weren't having a lot of problems, doesn't appear they're having a lot of problems now either. So again, this is just showing you here the green ones, the ones from the areas that are green, and then these are the ones that are out here in West Texas where it's super duper dry. So my upshot for this is that this guy Brune reported that more than 39% of his springs were going dry or had dried. And this guy Gary Garrett, who was part of my inspiration, he was the one that I was meeting out there. He's restored San Solomon Spring. He reports that 50% of Chihuahuan Springs, so that area of West Texas is the Chihuahuan Desert. That's why it looks so dry. He's saying that more than 50% of them have already dried. I just don't have the data. So, and these reductions were in the western parts and then in the coastal aquifers where all the people live. And the data that I have also suggests that Bruin was, that the trend that was happening then is still happening now, which is probably not surprising. Okay, and so this is interesting too. So it's super dry. I think you probably got that message. It's super dry out there. So these springs are really far apart and not well connected. And because of that, unlike our springs, they have all these endemics, which means they only occur in one spring or a few springs. And they don't occur very widely. This is real different than ours, where I'm getting the same species everywhere in terms of fish. So this one, these guys right here, these are little endemic pupfish that only occur, they're sassy little guys, they only occur in a few springs in West Texas. They're super abundant there, happy as can be, as long as you keep the spring flowing. But they don't occur very many places at all. And there's a number of different pupfish. As you go further west, they get even more restricted. There's one called the Devil's Hole pupfish that literally occurs in one spring that is a hole that's like the size of this room. That's it. The entire species occurs in that one spring. So those are the little endemic pupfish. This is an endemic catfish, which I did not get a very good video of, but there you go. That's a head spring catfish that only occurs, again, in just a few springs in this area. Interesting. Okay, so I'm not quite out of time. I'm going to show you Idaho really fast, because Idaho is completely different. So Idaho, I'd never been there before, and I didn't know anything about Idaho before I went. And the whole reason I went was because they have a whole bunch of great data. And it's all from the Snake River. The Snake River runs through here, or through that line right there is part of the Snake River, and it runs like that, basically from Yellowstone all the way out to the river, to the ocean eventually. But Idaho is interesting because there was volcanic action that long time ago spewed a whole bunch of lava. So this right here, that's a lava plain. We're looking at it here. That's a lava plain right there. And the river flows through the lava plain, and it looks like that. That's the lava plain. So this is above the Snake River. The Snake River is actually way down here, but this is that this is that lava plain. All of that is lava rock, basically. It's called Craters of the Moon State Park. It's awesome. It's really fabulous. This is the Snake River itself. So now I've gone south. And so here again is lava rock, and then this is the other side of the valley, and this is the Snake River going through it. So it's cut a canyon through the rock there, through that lava plain. And this is what it looks like when you get up close, a little further down or further up the river actually. And so again, here's the lava rock that it's cut its way through. And here's one of the springs. The craziest springs. They shoot out of the wall of the canyons. Not all of them, but a bunch of them. Never seen anything like it. So this is 1,000 Springs, and here's the river in the background, and this is also a little bit of the river as well. Again, they're shooting out of the wall of the lava rock after the river has cut it over, geologic time spans. This one's called Box Canyon. This was gorgeous. I hiked along this. And so the spring heads up there, and it runs through here and eventually down to the Snake River. This is Billingsley Creek, which is another spring. And I left this picture in here because it shows you how in part, how dependent on the water it is here too. So all these plants are growing right along the spring because Idaho also is kind of dry. This is where it starts. So this is up near Yellowstone. I drove almost all the way to Yellowstone to find the start of the Snake River. And it starts at this big, gorgeous spring. Looks completely different than the Snake River further down. This is more of that big spring, they call it, up near Yellowstone. Okay, so here we go. Here's the Snake River running from almost Yellowstone all the way out Idaho and eventually hooking up with, I forget what it hooks up with, but eventually to the ocean. And this is the only spring that I had that did not decline. So that's called Birch Creek. And I don't know exactly why that one did not. It is a little further west than some of the other springs I have, but all of the other springs, all these big, beautiful springs, many of them shooting out canyon walls. This one is called Devil's Wash Bowl. So there's like roiling water right there, and then it goes through this crazy canyon. And then that first picture that was on the front, the first slide I had was its run before it gets to the river. All of these guys are dropping like rocks. They're all, I'm sure you guys can see these trends. They're all declining a lot, all significant, all on the Snake River. So all but one of the ones that I've looked at so far are declining in Idaho. Why is that? Yikes. This was a beautiful one. That was called Blue Heart Spring. That was one of the only ones I saw that didn't come shooting out of the wall of a canyon. This is what it looks like upstream. So on top of that lava plain, so between the river and that Craters of the Moon State Park, it looks like that, or like that. They were pumping like crazy. And the water's coming out of the mountains. It's traveling through that lava plain and then getting to the Snake River. But they're intercepting it before it gets to the springs and irrigating crops. And there were lots of cows. They had these big dairy operations with the black and white cows. Here's more crops. They had all kinds of these spray rigs all over the place. And I was driving around and it's just water spraying everywhere. I'm like, well, no wonder why the springs are declining. Now I get it. They also had a whole bunch of wind farms too, tons and tons of wind farms. The fish aren't really highly endemic necessarily, although this little sculpin, I think it only occurs in Idaho. It's a little tiny thing. I mean, this thing was like this big. That's why my picture isn't that good. I saw it under my feet. I was trying to cool my feet off. I went, oh my God, there's a sculpin. Took a picture of it. And I have a video, but it stinks. It's really bad. But you can see there's a couple salmonids that swim in here. The fish are very different than the fish that we have here. A bunch of minnows too. So what do I conclude out of all of this? This is one of my favorite pictures, although it didn't blow up super well, of Madison Blue Spring. It's gorgeous. It flows into the with the Hoochie up north. So what do I conclude? Well, I should keep going. I think that's what I conclude. I should keep going with this project because there are springs that are declining all over the country, and unless somebody says something, then nothing is going to happen. The other reason I thought of this is because I used to teach at our law school. I used to co-teach a class on wetlands, and in the 80s, this came out in 1985, I think. There was this big report on wetlands. So somebody decided that wetlands were in trouble, and they surveyed wetlands all across the country and came up with this report. And this report went to Congress, and it led directly to the no net loss policy for wetlands that is still in effect today. It's not a perfect policy, but it's better than having nothing. And because they were able to say that this is the second report. This isn't the one from 1985, but this is a subsequent one, like maybe 1982 or 1992. At that time, they said 54% of the springs were lost. And they were lost in this case before 1985 to agriculture, after 1985. Oh, this one I guess it goes to 2010. It must have been. And the OOs, it's the wetlands are being lost to a variety of things, including a big chunk to development and a smaller chunk to agriculture. And so their wetland losses declined over time. So that this negative 458,000, that's 458,000 acres of wetlands lost. And this number is not quite accurate, but still the trend is good after they enacted the no net loss policy for wetlands. And so I'm trying to gather data so that I can make a similar argument. I'm not going to be going to Congress, I'm sure, but still, if I can publish some of this information, I'm hoping that it'll mobilize people to work on protecting springs a little bit more. So I'm going to leave you with my favorite fish video. Oops, wait, that didn't work. My favorite fish video, if it plays. No. Uh-oh, wait, hold on. I got it to play earlier. Here, wait, here, I think I can get it. There. It's a Florida gar.